Okay, in this topic we will be looking at the linear independence of vectors. So if we, for example, if we have some vectors, okay, linear independence of vectors. If we have some vectors such as u1, u2, u3, yeah, so such as this vector set u1, u2, u3, etc. up to say um, okay, up to in Rn. That means each vector has a n components. So these vectors will be linearly independent if and only if c1 u1 plus c2 u2 and then up to cm will be equal to 0. That means 0, that means every vector, every component of the vector will be 0. Okay. So this is the condition for the linear independence of vectors. So if this condition is not met, the vectors will be dependent. So there are of course many other theorems, but this is the basic definition of the linear independence. These theorems will help you identify certain vectors are independent or not, but it is difficult to remember all those theorems. So in most of the cases we can apply this basic definition. So let's see it with the help of one example. Example 1. So suppose if I have two vectors 1, 2 and 3, -1. So I want to know whether these two vectors are linearly independent or not. So for this, for checking this, what I can do is I can take these two vectors and then I can multiply these two vectors by the scalars c1, c2. Okay, 1, 2, this vector was multiplied by this scalar c1 and then plus c2, 3 minus 1, and is equal to 0. So if we can find the value of c1 and c2, which makes them equal to 0, 0, then we will say that these vectors are independent. Okay, these vectors are independent. If we cannot find the vectors as these such values, then we will say that the vectors are not dependent. Okay, so now let's try to use this concept in the augmented matrix. So 1, 2, 3, -1, and then we can bring this vector on the left hand side, so we can put like 0, 0 over here. So from the row operation, what we can do is I can multiply this by -2. Okay, so it will be -2 -6. Okay, and then you can also so this row operation will be minus row 1 -2 row 1 plus row 2 will be equal to will given as row 2. Okay, but anyway, here we can now directly see that it will be 1, 3, and then 2 minus 2 is 0, and 1 minus 1 minus 6 is -7, and then that will be 0 0, it will remain as 0 0 over here. So now this equation is in echelon form, so what we can find from here is that minus 7 C2 is equal to 0. So from here we can find C2 is equal to 0. And then from the first equation, what I can find over here is that C1 plus 3 C2 is equal to 0. Since now C2 is equal to 0, C1 will be also now equal to 0. So we found like C1 is equal to C2 is equal to 0. So this is the condition for independence of these two vectors. So that means the only values of C1 and C2 of these scalars are that which are 0, by which we can write these vectors as like this in this form. That means C1 plus C1 U1 plus C2 U2 will be 0. So only values will be C1 C2 is equal to 0. That will be the condition. So in any case, now in this case, for example, if we can so this is the condition. So it means that our answer is that these two vectors are independent. Okay, are independent. So in this case, this is only possible when all these scalars are 0. So independent. But we can for the later questions we can shorten this process as well. So for example, if we will get a matrix in the echelon form, then we will say that those vectors will be independent. If we cannot get the echelon form, then those vectors will be dependent. Okay, so this is another thing which we can apply. So let's see it with the help of another example. In this case, we take 3 vectors. Okay, so 1 minus 1, 2 2 3 5. Okay, so this is 1, this is second, and then this is third. Okay, I make it a little bit messy over here, but anyway, we can write it into one matrix. 1 minus 1, 2 2 and 3 5. Now we don't have to necessarily write 0 0 over here. That will not make any difference. So just apply the row operations. So by the row operations, what I can do is I can just add these two. I can add these two rows. Okay, so row 1 plus row 2, that will be row 2. So in this case, it will be 1 2 3 0 4 and 8. 0 4 and 8. And next what we can see over here is that now this is in the echelon form. Okay, or maybe I can further divide, then I can make it like 1 over here. So it will be like 1 2 3 and then 0 1 2 in this case. So if I want to now this is in the echelon form. Okay, and if we want to determine these coefficients, in this case we need C1 C2 and C3. These 3 coefficients I need. So the last equation will give C1 plus C2 is equal to 0 is equal to 0. C1 plus 2 C2 will be equal to 0. So in this case, no, actually the last equation will give C2 plus 2C3 equal to 0. So in this case, since we have three coefficients to find, three unknowns to find, but two equations only. So C3 will be a free variable. So C3 we will take as a free variable S1. And C2 will be then minus 2 C3. So it will be minus 2 S1. And then C1 will be from the first row. So for first equation, so it will be minus 2S1 and then plus 3S1, that is equal to 0. So C1 it will be C1 will be in this case it will be what will be minus 4S1 plus 3S1, so it will be S1. Okay, it will be S1. Okay, so now the question is, what does this solution tell us? Okay, so for example, the solution vector is C1, C2, C3 is in terms of these free variables S1 minus 2 S1 and n S1. What does this tell us? It tells us that we can choose any value of S1, okay, and then we can get the values of C1. So for example, if you choose the value of S1 as 0, so all of these C1, C2, C3 will be 0. So which is the condition for condition that these vectors are independent. However, this is not the complete answer. Well, only for these particular values these are independent, but this is not the situation. S1 can have any value. So for example, if S1 has a value of 1, okay, a value of 1. So for example, 1 minus 2, so these values will become 1, minus 2 and 1. So then what will we get? Okay, so we will also get 0 over here. We will also get 0 over here. For example, over here, 1 times 1 minus 1 minus 2 times 2, 2, and then 1 times 3, 5. So what do we get from here? 1 plus 4, 1 minus 4. 1 minus 4 plus 3, and then minus 1 minus 4 plus 5. So we get 0 is equal to 0. So equation is satisfied. But in this case, we are using non-zero coefficients C1, C2, C3 to make them 0. So for the linear independence, all the coefficients C1, C2, C3 must be 0. Yeah, I think I should write one condition over here, is that this is for this linear independence, all these coefficients C1, C2 up to Cm should be equal to 0. But here we have found a solution of this in which the coefficients are 1, minus 2 and 1, which is not equal to 0. So this means that these two vectors are not independent, so they are dependent. Okay, these three vectors are dependent. Okay, so that means we can get from one vector the other vector, okay, by multiplying or adding the vectors, multiplying the vector by a scalar and then adding them together, such as in this case. So for example, what we can do is we can multiply this by 1 minus 1 by 1 and 2 minus 2 by minus 2. So what we get is so for example, in this case, if we have this vector 1 minus 1, and then I multiply it by 1, and then instead of minus 2 I take 2 value, So it was 2, 2.